Okay, 5.5 is the double angle and the half angle formulas, and then we will cover some more formulas in the next class. Okay, the double angle formula is saying it's the sine of 2u, the cosine of 2u, and the tangent of 2u. These formulas are derived using the sum and difference formulas from section 5.4. So for example, the sine of 2u is the same as the sine of u plus u. And if you recall the formula from last section, that would make it sine u cosine u plus cosine u sine u, which makes it 2 sine u cosine u. Okay, for cosine, the formula for the cosine of u plus u is cosine u times cosine u minus sine u times sine u, which is where they come up with cosine squared u minus sine squared u. These other two forms of it are the same, but they're using the Pythagorean identities to rearrange it, so it's in terms of cosine or sine. Okay, we did not memorize the tangent formula, but if you look back at it, if this was tangent of u plus u, this would be tangent u plus tangent u, which is 2 tangent u, 1 minus tangent u, which is 1 minus tangent squared u. Okay. We use these formulas sometimes just to make things easier to solve or easier to work with. Okay, so for example, when I'm going to solve 2 cosine x plus sine of 2x, the reason this is difficult to solve, besides the fact that it has a cosine and a sine in it, is that this is the cosine of just x, and this is the cosine, and this is the sine of 2x. So they're kind of mixed. Okay, but the sine of 2x is the formula written up here. So I'm going to replace sine 2x with 2 sine x cosine x, and then I'm going to solve it that way because then at least they will both have an argument of x. So 2 cosine x plus, and I'm going to replace sine 2x with 2 sine x cosine x equals 0. Okay, now since everything's kind of in terms of x, I can solve like normal. This actually has a common factor. I can take out 2 cosine x. And then what am I left with? I'm left with 1 plus sine x equals 0, which gives me cosine x equals 0 and sine x equals -1. Okay, for the cosine equation, the cosine is 0 at pi over 2 plus 2 pi n to capture all the coterminal angles, 3 pi over 2 plus 2 pi n to capture all the coterminal angles, and the sine is equal to -1 at 3 pi over 2, which I've already stated. Okay, so this is my solution. The solution could also be written as pi over 2 plus pi n, because by doing that, I would capture the 3 pi over 2 at the same time. But either way is fine with me. Okay, for example 2, it says solve 2 cosine squared x plus cosine of 2x. Okay, and it's the same thing. One of them has a cosine of x and one of them has a cosine of 2x. So I'm going to make a substitution for cosine 2x. Okay, now the thing is there's actually 3 forms for cosine 2x. I can use any of those 3. They'll all give me the same answer eventually. Okay, if I look at my equation, since this is in terms of cosine, I'm going to use the formula that's also in terms of cosine, just so that everything will match. But that does not mean the other forms wouldn't work. They would work. I would probably just have to use a Pythagorean identity to later make them match. So I'm going to replace cosine 2x with 2 cosine squared x minus 1 equals 0. Okay, let's go ahead and solve this. What is this? 4 cosine squared x. Okay, depending if you like to factor or if you like square root, you could solve this by factoring or by using square root. Okay, let's see. The cosine of x is equal to plus or minus 1/2. So what are my solutions? Okay, I'm going to write it 2 different ways so you can see the 2 different ways to write it. I could just list out all the points. 2 pi over 3 plus 2 pi n. Oh, I skipped pi over 3 plus 2 pi n. 4 pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. This is a good way to write it. But if you notice the pattern, because when there's a plus minus on cosine and sine, there is a pattern. These are all my 4 answers. So actually, if pi over 3 is an answer, the one across from it's an answer as well. So if you notice that, you could write pi over 3 plus pi n, and that will capture the 4 pi over 3 in the opposite quadrant. And I could do 2 pi over 3 plus pi n, and again, that would capture the 5 pi over 3 in the opposite quadrant, and it would involve less writing. Both of these are equally correct. Whichever one makes you feel more confident is the one you should use. Okay, so for example 3, we're going to evaluate sine of 2 theta, cosine 2 theta, and tangent of 2 theta. And they've given me some information, which again is very reminiscent of what we did in chapter 4. Okay, so let's see, sine 2 theta, cosine 2 theta, tangent 2 theta. They gave me that the cosine of theta is 5 over 13. They tell me from 3 pi over 2 to 2 pi, which means I'm in quadrant 4. Okay, let me solve for this sine of theta, because then I can use that to evaluate the other values I'm trying to evaluate. I'm going to do the XYR method, but remember, you can do a picture, you can do identities, you can do whichever way. Okay, so this is going to be 5 squared plus y squared equals 13 squared. Y equals, this is quadrant 4, so the y is actually going to be negative 12 for this thing. Okay, now I'm going to try to actually evaluate the answers. Okay, what they want me to find the sine of 2 theta first. 2 theta. I'm going to rewrite the formula just because it's your notes, but the formula would be 2 sine theta times cosine theta. So this will be 2 times the sine of theta would be y over r, so that is negative 12 over 13. And then the cosine of theta was given to me as 5 over 13. Okay, if I multiply this out, I get negative 120 over 169 for the sine of 2 theta. And I have no idea what theta is, but this is what the sine would be if I doubled it. Okay, let me try cosine. See, cosine 2 theta. Now cosine has 3 formulas. Depending on my information, I might pick a different one. Since I have the cosine and the sine, I'll just do cosine squared theta minus sine squared theta. But if I only had cosine or I only had sine, I might use a different format of the equation. They all are just rearrangements. What is the cosine? The cosine is given to me. The cosine is 5 over 13 squared minus sine is negative 12 over 13 because it's y over r squared. So the cosine of 2 theta would equal to negative 119 over 169. And I can calculate this even though I have no idea what theta is. I know it's in quadrant 4. Okay, now for the tangent of 2 theta, I'm going to calculate it 2 ways so you can see how to do it both ways. After you see it both ways, you will probably prefer one over the other. Okay, the first way I'm going to do it is by using the formula. Okay, the formula is 2 tangent theta over 1 minus tangent squared theta. Okay, so 2 times the tangent. Tangent is y over x, so negative 12 over 5 over 1 minus negative 12 over 5 squared. Okay, I'm going to go ahead and try to simplify this. Let's see, 1 minus 144 over 25 Okay, 25 over 25 minus 144 over 25 will be 119 over 25. Let's see, I'll do reciprocal. Let me cancel out a 5. Okay, that gives me 120 over 119, and the negatives cancel. So the tangent of 2 theta is 120 over 119, and that's using the formula. Okay, or because I've already done so much work to find the sine of 2 theta and the cosine of 2 theta, or to find the tangent of 2 theta, I could use my answers for sine of 2 theta and cosine of 2 theta. The sine of 2 theta was negative 120 over 169, and then the cosine was negative 119 over 169. The 169s cancel, the negatives cancel, and I still get 120 over 119. So if you happen to have already calculated the sine of 2 theta and the cosine of 2 theta, I would use those to calculate the tangent rather than using the formula. Okay, the next formulas in this section are the half angle formulas, and you should know these will be given on your test, so you do not need to memorize these. Okay, these are derived using the double angle formulas, but I am not going to show you the derivation this year, I'm sorry. Okay, so if I want to find the sine of u over 2, it says it's plus or minus the square root of 1 minus cosine of u over 2. Cosine of u over 2 equals plus or minus the square root of 1 plus cosine of u over 2. Okay, the plus or minus is a lie. Okay, the sign of this right here, the sign depends on the quadrant in which u over 2 lies. Okay, so if I know that u over 2 is 10 degrees, I know it's in quadrant 1, so these would both be positive. If u over 2 ended up being 170 degrees, that's in quadrant 2, and I would know the cosine would be negative and the sine would be positive. Okay, so plus or minus is a lie. It is based on the quadrant it exists in. Okay, so let's look at example 4. Example 4 says find the exact value of cosine of 112.5, which I don't know what that is, but I'm guessing it's half of some useful angle. Okay, before I even start, I'm going to determine the sine for cosine of 112.5. Okay, 112.5, 90, 112.5, that's in quadrant 2. Okay, so this is negative, the cosine's negative, because it's in quadrant 2. So I already know the sign. There's no plus or minus nonsense. Okay, I'm pretty sure this is dividing something in half. Okay, so the cosine of 112.5 degrees is the same as the cosine of, what's that doubled? 225 degrees divided by 2. Do I know 225 degrees? Yes, because that's 180 plus 45 degrees, which puts me at 225 is 5 pi over 4. Keep in mind, 225 is 5 pi over 4. Okay, now let me look at the formula. Okay, this is what the formula tells me. Okay, plus or minus, it's going to be negative because I said 112.5 is in quadrant 2. Okay, let me write the formula. This is cosine, so it's 1 plus the cosine of the number I divided by 2, so the cosine of 225 degrees, and the whole thing divided by 2. Okay, let me see if I can figure this out now. Okay, the negative is known. Okay, cosine of 225 degrees, remember that's 5 pi over 4. So 1 plus, the cosine of 5 pi over 4 is negative root 2 over 2. Okay, the whole thing is over 2. Okay, now how you simplify it from here is kind of up to you. I'm going to work with it and then you're going to figure out which steps work best for you. This is negative. I'm going to do a common denominator on the top. So I'm going to make that 2 over 2 minus root 2 over 2. So that's 2 minus root 2 over 2. but then the whole thing is still over 2 because of that 2 that's in the formula. Okay, I'm going to keep working with this, and your work could be different because I don't know how you work with fractions. I'm going to times by the reciprocal inside the radical. So I'm going to make this 2 minus root 2 over 2. Since I'm dividing by 2, I'm timesing by half. Two times 2 is 4. Okay, so what's my final answer? Negative square root of 2 minus root 2. And the square root of 4 is 2, so I can go ahead and leave that as a rational denominator. Okay, and again, it was only negative because it was in 112.5 is in quadrant 2. And this is the exact value for the cosine of 112.5. Okay, one last example. This is involving the half angle formula again. We're going to solve. So let's look at this. Cosine squared x, I don't have a problem with that. Sine squared of x over 2. I don't really like that some of this is in terms of x and some of this is in terms of x over 2. So I'm going to use the half angle formula to replace the sine squared of x over 2. Okay, so cosine squared x, I like you. Sine squared of x over 2, I don't like you. So I'm going to check the list to see what the sine of x over 2 is. And it does have a weird plus or minus situation. I'm going to go ahead and put plus minus because I don't know what x is. It's between 0 and 2 pi, which is a very broad range. Okay, and again, this half angle formula will be given to you on the test, so you don't need to memorize it, but you do need to use it. Okay, so that's the sine of x over 2 squared. Okay, let's work with this. Okay, now I have a plus minus. If I do positive squared, I get positive. If I do negative squared, I still get positive. So the sign actually doesn't matter because I'm squaring it. The squared will cancel out the radical, and I'll get 1 minus cosine x over 2. Okay, this is now solvable. I'm going to times the 2 to the other side. I shall put it in standard form and then try to factor it, although if you prefer the quadratic formula, you could quadratic formula it. Plus 1 minus 1, that's plus 2 cosine my cosine. Okay, that works. Cosine x is 1/2, and cosine of x is negative 1. I am restricted for 0 to 2 pi for x, so I'm just going to list the answers that are between 0 and 2 pi. So the cosine of x is 1/2 at pi over 3 and 5 pi over 3. And then the cosine is equal to negative 1 at pi. So those are the three answers that occur from 0 to 2 pi.